Hello everybody, in this question we are given fx is equal to 3 minus 4x minus 9x squared. Given that fx can be expressed in the form a minus b times x plus c whole square, where b and c are positive constants, we need to find the value of a, b and c and write down the maximum value of fx. Then the equation fx has roots of alpha and beta, and without solving we need to form a quadratic equation with integer coefficients that has the roots 3 alpha over beta and 3 beta over alpha. And then we need to show that x plus y cubed is x cubed plus y cubed plus 3xy times x plus y, and then gx is 3x squared plus qx plus r, where q and r are constants. The equation gx is 0 has roots alpha minus beta and alpha square minus beta and beta square minus alpha, where alpha and beta are the roots of the equation fx is 0. So using your answer to part D, we find in simplified exact form the values of q and the values of r. So we need to find these values q and r. So that would complete the question. So to get on with the answering this question, so the first bit, that is fx can be expressed in the form this, so I would write, so we start with part A, and fx I can also write as minus 9x squared minus 4x plus 3. So then I can complete the square, so that I can write that is equal to minus 9 9 times 9, that's 9 is 81. Then we need to add 9 times 2 is 27 and 4, so that we get it as 31 over 9. So and rewrite this as 31 over 9 first, and then minus 9 times x plus 2 over 9 whole square. So then we need to find a, b and c. So here a is 31 over 9 and b is 9 and c is 2 over 9. So that's the value of a, b and c. So that completes part A. So find the value. We found that, so that's done. So the next bit is we need to write down the maximum value of fx. So for the b part, so from here we can see 31 over 9. because this bit has to be 0. So the maximum value is 31/9. So on to so that's done as well. So then they're saying the equation fx equals 0 has roots alpha and beta. The equation fx is 0 is this one, fx. So without solving the equation fx is 0. So we need to form a quadratic equation with these coefficients. So we already know. So no, we don't know. Sorry, we have to in terms of alpha and beta. So alpha, beta are the roots. So we can do the sum and product of the roots. So sum of the roots of fx is equal to 0. So that's part C. So I write it here. Part C. Sum of the roots of fx equals 0 are, so that would be alpha plus beta, and that is equal to so I can rewrite fx. I wrote it before. So minus 9x squared is 4x. So it is the sum of the roots is minus b over a. So minus, so b is 4, minus 4 over minus 9. So that is minus 4 over 9. And the product of the roots so maybe I can just that's c over a. So here c is 3 over minus 9 minus 1 over 3. So that's the product of roots. So hence the equation, so we can now write quadratic equation as is given in the form x squared minus sum of roots times x plus product of the roots equals 0. So which one am I doing? Yeah. Oh, so we have to write that. So that's this. But the sum and product, I haven't found it out yet. So they're saying that we need to form a quadratic equation for and, and this equation has roots of 3 alpha over beta. So I need to do the sum of these roots, right? So product of the roots of this I found out. So sum 3 alpha plus beta over beta. So I need to do 3 alpha over beta plus 3 beta over alpha is 3 alpha squared alpha beta So, and straight away do it as whole square. So now I can put in the values, substitute the values from here. So alpha right, I can do that. That is equal to 3 times minus 4 over 9 square minus 2 times minus 1 over 3 over minus 1 over 3. So we can say that the sum of the roots, so it will be 3 times 16 over 81 minus or plus 2 over 3 and multiplied by minus 3. So because we have it dividing by 1/3, so let's multiply by 3 minus 3. That goes up in the numerator. So then I have this is equal to 3 times by then 81. So that's 16 plus 3 times 27. 2 times 27 is 54 times minus 3. 3 and 3 is 9 times 9 is 81. That is 70 over 9, the minus sign. Okay, so that's the sum of the roots, right? So then I need to do my highlighter or just 70 over roots. So that's the sum, right? We need to now work out the product of the roots. So the product of the roots, so we would just need to multiply these, 3 alpha over beta multiplied by 3 beta over alpha. And that is nothing but 9. So the product of the roots is 9. So I can now write the equation, the x square minus sum of roots. Required equation would be x square minus sum of the roots, so minus 70 over 9 times x plus 9 equals 0. So I can write this as 9x squared plus 70x plus 81 equals 0. And that's the answer to the part C, which is now concluded. So we've done that. Now for the part D, which is x plus y whole cube, we need to do that. So say B. I can write this as, we can do this various ways, I'm just doing it this way. So x plus y squared times x plus y. So that is equal to x squared plus 2xy plus y squared, and that multiplied by x plus y. That is x cubed plus x square y plus 2x square y plus 2xy square plus y square x plus y cubed. So that is equal to x cubed plus x square y 2xy 3 x square y plus 3y square x y square plus y cubed. So that's proved. That's D completed. That's done. So now I am left with the e-bit. So it's saying gx is 3x squared plus qx plus r, where q and r are constants. Equation gx is 0 has the roots these, where alpha and beta are the roots of the equation there. So we can just substitute the values, of whenever we get alpha plus beta and alpha beta. So then we need to also find the values of q and r. So sum of the roots of gx would be minus q over 3. So we can write that. This is part E. Sum of the roots of gx is minus q over 3. Product of roots of gx is equal to r over 3. Right? So now we need to equate these, We have sum of the roots, this bit. We add them up. Alpha square minus beta plus beta square minus alpha. I should equate it to minus q over 3 and find the value of q. So alpha square minus beta plus the beta square minus alpha. Beta square minus alpha is equal to so that is equal to what did I write? Alpha square plus beta square, that is equal to alpha plus beta whole square So we know what alpha plus beta is, because it's the roots of the original equation. So where did I write? Yeah, minus 4 over 9, alpha plus beta. So it's minus 4 over 9 square. And what is the product of the roots, alpha beta? Minus 1 over 3. And that is 16 over 81 plus 2 over 3 plus 4 over 9. And that is equal to 81 27 times 254 plus 36. So I get now I have written the sum as minus q over 3. So hence minus q over 3 is equal to 106 over 81. 3 times 27 is 81. Therefore q is equal to minus 106 over 27. That's another result obtained. Q. So I need to now find out R. We need to find what R is, isn't it? Lots of lines here. So I need to find what R is. And I have done the sum of the roots. I'd like to do the product of the roots as well. So the product of the roots. So I'll write it as alpha square minus beta multiplied by beta square minus alpha. So that is multiplying it out. So alpha square beta square minus alpha cube minus beta cube plus alpha beta. That is alpha beta, the product of the roots squared, plus alpha beta, product of the roots, minus of alpha cube plus beta cube. So we can get this alpha cube plus beta cube from our expansion here. So we can write, that x plus y whole cube minus, sorry, I should have written it, added a step here, plus 3xy times x plus y plus y cube, isn't it? I missed this step, you know. So so maybe I should write it in green so it's easier. It looked like it was done earlier when it wasn't. So that is x cubed plus 3xy times x plus y cubed. So that's that. And then if I just switch my pen to some blue. So I can say like x plus y cubed minus 3xy times x plus y. What it is. Yeah. And that is equal to x cubed plus y cubed. So I can use that here. So I can say that this is equal to alpha beta square minus x plus y whole cube So that's alpha plus beta whole cube and minus 3 alpha beta multiplied by alpha plus beta. So now I can put in the values. So I can say alpha beta is minus 1 over 3. And alpha plus beta minus 4 over 9. So I can do that here. Alpha beta, that's minus 1 over 3 square plus minus 1 3 minus alpha plus beta, so minus 4 over 9 cube minus 3 times minus 1 over 3 times minus 4 over 9. So that is 1 over 9 plus, minus 1 over 3 minus 16 over, no, that's not 16, it's a cube, so that would be 16 times 4, 64 over 81 times 9 is 729. Yeah. So yeah, the plus 64 over 729, and then I get plus 1 sorry, that cancels out. 3 and 3 go away, so it's minus 4 over 9 plus 1. So that's minus 4 over 9. So I get so 1 over 9 minus 1 over 3 minus, I can do this here, minus 4 times, so 9 times 81 9 times 81, so I get 324. So that's minus 324. And that is 729 times 89 times 81. So that's 81 minus, so 243, and then minus is plus, 260. So minus 324 plus 64. So I hope I'm getting it right, or I'll have to do it again. Maybe it's an error. Don't know. So I must have missed something somewhere. Ah, so that's where I missed. It's the minus sign I missed, didn't I? So I missed the minus sign, and then so I would get minus 324 and 64. So then it would be 1 over 9 minus 1 over 3, and then minus 729 is actually a plus. So 324 plus 64, that's 8. And the 6 plus 3 is 8, and 388. So I get then equals 729 in the denominator, 81 minus 3 times 3, it's 243 plus 388. So that is going to give me so I get 226. So that is 226 over 729, which is the right answer. Now this is equal to, and I should also write here, product of the roots. You know, if you were to look at the equation, so the product of the roots is r over 3. So I'm going to write, therefore r over 3, 226 over 729, and then 3 times it's 243. So therefore r is 226 over 243, and that is one value of r. We've already found the value of q, and so this would complete this question. Yep, now done that as well.